Okay, so we are continuing to solve systems of linear equations. We've worked with solving systems graphically, so today we're going to try the next method, which is called the substitution method, which is basically solving a system algebraically. So how can you use substitution to solve a system of linear equations? I put the steps here for you. Our first example is y equals 2x plus 3 and y equals 5x. Again, if you have graph paper available, go ahead and graph it and find the coordinate where the two lines intersect. However, if it asks you to solve a system algebraically or by the substitution method, you have to do it that way. You could always check your answer graphically. Step 1. Solve one of the equations for one of the variables. Well, looking at my system, they're both y equals. So step 1's already done. Step 2, you're going to substitute the expression from step 1 into the other equation and solve for the other variable. What that means is you're going to take an expression from one system, one equation, right? Y equals 2x plus 3. That's what y equals. Y equals 2x plus 3. And we're going to substitute it into the second equation wherever we see a y. So again, y equals 2x plus 3, y equals 2x plus 3, y equals 2x plus 3. We're going to put it right where we see a y. So what does y equal? 2x plus 3, which equals 5x. See how that works? You could also do it the other way. Looking at the second equation, y equals 5x, and plug it in to the second equation. We are substituting one expression into the second equation. Now, looking at this new equation, 2x plus 3 equals 5, notice I only have x's, so I'm going to go ahead and solve for x. Remember, the goal is to get a solution to a system which is an ordered pair or a coordinate. So we need an x value and we need a y value. Go ahead and solve this equation by bringing the variable terms to the same side. 3 equals 5x minus 2x is 3x. Divide by the coefficient and we get x is equal to 1. I'm going to go ahead and put x equals 1 into my solution. That's step 2. Step 3, substitute the value from step 2 into one of the original equations and solve. So I'm taking my x equals 1 and pick one of these equations. Which one do you like better? Let's pick this one. You can pick either one, but definitely always go back to the originals. Y equals 2x plus 3, and I'm merely substituting my x value in now. So y equals 2 times, what was x? 1 plus 3. Simplify, y equals 2 times 1 is 2 plus 3. So y is equal to 5. And I'm going to go ahead and put that in my solution. If we didn't pick the first equation, let's say we picked this one, y equals 5x. Again, I would substitute in 1 for x, so y is equal to 5 times 1. And we would still get y is equal to 5. It doesn't matter which equation you use. And that's it. My solution, algebraically, solving this system, is 1, 5, that coordinate 1, 5. We said the answer was 1, 5, so I have this same example here. Let's just check it graphically. I'm going to go ahead and graph y equals 2x plus 3. I'm going to start at my y-intercept of 3, and apply the slope of 2. Remember, for systems, you want a lot of the coordinates or the dots on your line, a lot of these solutions, and connect. Let's change the color, and now we're going to graph y equals 5x. The y-intercept is 0. I'm going to start it at the origin and apply my slope of 5 over 1. Up 5, 1, 2, 3, 4, 5 over 1. Boom, look at that. 1, 2, 3, 4, 5. And I'm going to connect. So where do these two lines intersect? At this coordinate here, which is indeed 1, 5. Let's try another example. So here's my system. Y equals x minus 1. What's going on today? Y equals x minus 4. y equals 4x minus 10. I'm going to take an expression from one equation and substitute it into the second one. Y is equal to x minus 4. Y equals x minus 4. So wherever you see a y, I'm going to replace it with x minus 4. And then finish the equation. Notice I only have x's. So let's go ahead and solve for x. Let's subtract x from both sides. I'm left with negative 4 is equal to 4x minus x is 3x minus 10. Let's go ahead and add my constant. 3x is equal to 10 minus 4 is 6. Divide by the coefficient, so x is equal to 2. Let's go put that in my solution. Now, pick any of the original equations. Which one do you like? Let's try the second one. Y is equal to, is this a y? Y is equal to 4x minus 10, and I'm substituting in the x value I just got. So y is equal to 4 times 2, because that's what x is, minus 10. So y is equal to 4 times 2 is 8, minus 10, and 8 minus 10 is negative 2. So the solution to this system is located at the coordinate 2, negative 2. Here's another example. Again, you're going to solve one of the equations for one of the variables, either x or y. This one's already solved for y, so we're good with step 1. Step 2, substitute the expression from step 1. So y is equal to 2x minus 4. That's what y equals. And we're going to substitute it wherever we see a y in the second equation. So our new equation will be, let's take the second one, 7x minus 2 times the quantity of, what was y equal to? We're going to substitute it with 2x minus 4 equals 5. Again, notice now I only have x's. So let's go ahead and solve because we want an x and a y. So use what you remember about solving multi-step equations. Remember you want to distribute the negative 2. So you get negative 4x. Negative 2 times negative 4 is positive 8 equals 5. Let's combine the like terms. 7x minus 4x is 3x plus 8 equals 5. Eliminate our constant. 3x is equal to 5 minus 8 is negative 3. So again, x is equal to negative 1 once we finish. So let's put negative 1 in for x. Now, step 3. Substitute the value from step 2 into one of the original equations. You can pick either equation up top. Just make sure it's original, meaning from the problem. So we're going to go ahead and pick this one because it's nice and cute. Y is equal to 2x minus 4. But you can pick either one. And I'm just substituting in my x value, which I got as negative 1. So y is equal to 2 times negative 1 is negative 2 minus 4. What's negative 2 minus 4? Negative 6. So this is the solution to that system, algebraically, or the substitution method. Last example, 2x minus y equals 6, and x equals y minus 1. Again, step 1 is to solve one of the equations for one of the variables. The second equation is already in x equals form, so we don't have to do anything. If it wasn't in x equals or y equals form, you have to use what you know about solving equations to isolate one of the variables. But this is what x equals, y minus 1. So I'm going to substitute that in wherever I see an x into the other equation. So I've created now 2 times what was x? Y minus 1. Finish the equation. Minus y equals 6. Okay. Now I only have y, so let's solve for y. I'm going to distribute. 2 times y is 2y. 2 times negative 1 is minus 2. Minus y equals 6. Let's go ahead and combine these like terms. Y is, or 2y minus y is 1y minus 2 equals 6. Go ahead and add the constant. So we get y is equal to 8. We'll put that in our solution, right? X, y. Now, that was step 1 and step 2. Now step 3, substitute the value you got, 8, into one of the original equations. Pick either one that you like. Let's pick this first one, 2x minus y equals 6. So 2x minus y, we got 8, equals 6. So now let's solve for x. 2x minus 8 equals 6. Let's add 8 to both sides. 2x is equal to 14. So what does that mean? X equals 7. Put that in our solution. So the solution to this system is at the coordinate 7, 8. Let's go try some on our own.